put the comment in parentheses before we get too far into this section. Delta H of reaction is the energy associated with the reaction, but sometimes they're specifically labeled. COMB stands for a combustion reaction. PREC stands for a precipitation reaction. So if you see some words you're not positive about, most likely they are the type of reaction, and you can still treat them as delta H of reactions. What does this all mean? It means that when we write delta H like this on the side of the reaction, we have a lot of extra information. First of all, we know that this reaction needs heat. Know that this reaction, the word is endothermic. We know that if someone wanted us to write the heat as part of the equation, because it's required, it's a reactant, and it would be like this, 153 kilojoules. Notice we've switched to kilojoules also. Earlier in the other section of the chapter, we weren't talking about kilojoules, we were doing all these reactions in joules. So enthalpies of reactions on the molar, 1 mole, 2 moles, mole scale, they're in the 150,000 joule range. So the tables in the charts don't want to constantly write numbers that large out. They just want to save space. And so they just put at the top of the column that the unit is a kilojoule per mole. And they put it like this. If you had to use this equation, this one isn't combined with the MCAC equation, but if you had to use a delta H value in an equation like in JINGHAM 2, you would need to definitely be aware as to whether or not the equation is expecting it to be in joules or kilojoules. And most of the time, you're going to have to convert it back to joules. Well, notice that this version of the reaction is the way it should be. It's the lowest molar ratio. So it just shows that you can't reduce this any further and everything is a whole number. So this is also a way to do more factor labels. You'll like this in a way because it's not new. We're just adding one more tool to your factor label toolbox. So in all of these cases, the energy is 153. What matters is looking at those coefficients. This is 153 kilojoules in 1 mole of zinc. Or if you flip it over, in 1 mole of zinc, there are 153 kilojoules. That's the conversion. If you're going to take a certain amount of grams of zinc and figure out how much energy in this reaction it will produce, or rather in this reaction, how much energy it will absorb. So this is 153 kilojoules in 2 moles because this right here is a 2. So in 2 moles of HCl, 153 kilojoules. Or in 153 kilojoules, there's 1 mole of zinc. Understood one there. Same here, zinc chloride. And then also our H2 is 1 mole and 1 mole. So you'll notice we basically can take the number that's over here and match it with any reactant or any product and turn energy and relate it to mass. Now let's do this first reaction. So write a possible thermochemical equation for 2 moles of sodium hydrogen carbonate. So the example's right there. So 2 NaHCO3 solid. And it says it's absorbing 130 kilojoules. You could put your heat on the left or the right of the reactants. So it's okay for me to put it there. And it's producing 1 mole of Na2CO3 solid and 1 mole of water. Water vapor is water as a gas. And 1 mole of CO2 gas. When you count these up, it should be balanced. Notice that if I were to write the delta H of the reaction, if I were to write the delta H of the reaction, I would write it over here as 130 kilojoules. So notice this is 130 kilojoules per 1 mole of CO2 per 1 mole of H2O per 1 mole of sodium carbonate per 2 moles of sodium hydrogen carbonate. So then let's see how many moles will be consumed if 75 kilojoules of heat were consumed in the reaction. And this is supposed to be a 65, if 65 kilojoules. So we take our 65, that's what we start with, and then we have this conversion factor. So because it's asking about the NaHCO3, I'm going to go over here and I'm going to say, oh, I have a coefficient of 2. With any time we have units, we need the kilojoules to cancel on the bottom. And now you know you can relate kilojoule to moles. And the reason we have a 2 in front is because our reaction had a 2 in front. When you do this math, and you might be able to do it in your head, you're going to get 1 mole of NaHCO3. And look, that's how many we produced, was 1